Hello and welcome. My name is Leah Kopke, and this is my podcast, Ambient 3D Animations, where we cover all things 3D modeling and simulation related. Today we are going to talk about what is expected advect distance in voxels inside of Cinema 4D. Now that is a mouthful and it sounds really complicated, but it isn't as complicated as it sounds, and we are going to go in depth so that you understand it and can use it for your Pyro simulations. So let's go ahead and get started. So to start off with, I have a few Pyro simulations here, and they're all controlled by a different simulation scene. If you're interested in learning about the simulation scene or the Pyro emitter in general, I'll leave links to those episodes in the description of this video. I'm going to start this at the beginning and press play. And you'll see we have 3 fires. And they look quite a bit different. And they all have the same Pyro emitter settings. They all have the same amount of fuel in them. But they all look very different. And there's only one setting that I have changed between these 3. And that is the simulation scene setting for the expected advect distance in voxels. So this one is the one we have on our left hand side, these settings here. This one has an expected advect distance of 4 here on the left. In the middle, we have an expected advect distance of 8. So that's this one here, the medium size one. And the one on the right has an expected advect distance of 16. So this is the only setting that is different between these 3. And I think it's easier to see the difference between the setting at different amounts when you do have fuel activated for your Pyro emitter. So you can see in the tag, I have fuel turned on, and it is just turned on to the default settings for the fuel. So if you just check this on, you'll have the same settings as me. Each one is set to continuous, and the fuel set is 10. So that is what we're looking at here, and we're going to talk about what this is. So the first thing that we need to know is that the Pyro simulation inside of Cinema 4D is considered a fluid simulation. So it's helpful to know what a fluid is in terms of, it's hard to say words today. It's good to know what a fluid is in terms of physics. So I have the definition pulled up here on Google. In physics, a fluid is a liquid, gas, or other material that may continuously move and deform, flow under applied shear stress or external force. So it can be a liquid or gas in terms of physics. And then we also need to know what advection is, because this setting here inside of our simulation scene is called expected advect distance. And we're talking about voxels. And if you've been here on this podcast, you'll know that voxels are basically a 3D pixel. They're kind of like little cubes that make up the form of your simulation. So these fires are all made out of voxels. And you can control your voxel size and such. So we've covered that before, but what's new is this advect and what that means. So I also pulled up that definition. And here it says, in engineering, physics, and earth sciences, advection refers to the transport of a substance by bulk motions. A vivid example of advection is the transport of pollutants or silt in a river by bulk water flow downstream. During advection, a fluid transports conserved quantity or material via bulk motions. The properties that are carried with the advected substance are conserved properties such as energy. Another common advected quantity is energy or enthalpy. In general, any substance or conserved extensive quantity can be advected. Basically, the motion of the fire is moving the density of the fire, the smoke and the flames and all of that. So this is all being moved. And when it's talking about advect distance, it is talking about the distance in voxels that it can move per substep. So we talked about max and min substeps inside of Cinema 4D and how that works in the last episode. When we're talking about voxel distance, we're talking about that distance per substep, so per calculation. And the substeps are how many calculations are done per frame. So what's happening is that when you increase this number, you're allowing Cinema 4D to have this calculate that this fluid simulation, which we have as a Pyro simulation, this fluid simulation can move further in terms of distance in voxels per frame when we increase this number. So that is why this one has the longest distance in voxels as 16, and it is the biggest fire. So that's the reason why, and that's a little bit of science. And I found it interesting, though, doing the research for this video, and I hope you find it interesting, too, and found this helpful. If you want to understand how more simulations work here inside of Cinema 4D, or just learn more about the Pyro emitter or anything else in general in regards to that, please hit like, subscribe, and ring the bell so that you'll be notified when the next episode comes out. And thank you so much for taking the time to do some Pyro simulations with me here on Ambient 3D Animations.